So let's first take a look at part A here. We've got two different functions. We've got square root of x and 6 minus x, which they've given us a point of intersection for those of 4, 2. And then we've got the region R that's bounded by those in the x-axis. We want to find the area of R. So we've got two different ways that we can go about finding this area. We could do it in terms of x, or we could do it in terms of y. And if we do it in terms of x, what do we need to do?
Split it up into two different integrals.
Either split it up into two different integrals or do one integral and then find the area of the other piece, which is just a triangle, which would also work. But let's do it in terms of x. So if we do it in terms of x, it should be the integral from 0 to 4 of root x dx, which should be 2/3 x to the 3/2 from 0 to 4. And what does that give us? 4 to the 3/2 should be 8, right? Square root of 4 is 2, cubed is 8, times the 2/3 is 16/3. And then that'd be this section, right? And then if we want to find this other section, you could, if you wanted to, integrate 6 minus x from 4 to 6, or we could just see that this is 1/2 of the base times the height, which would be 1/2 of 2 times 2, or 2. So what should we end up with? 16/3 plus 2, which should give us 22/3. Everybody good there with part A? Any questions on part A?
Yeah. No.
Okay. And so if we wanted to, we could have done this in terms of y, right? Which would have required one integral and no extra like area nonsense to attach to it. So if we wanted to, we could have done an integral from lowest y value, which was 0, to the highest y value, which is 2, of the rightmost function, which was this linear function, minus this function. So we'd have to solve both of them for x. So if we have y equals root x, that'd be x equals y squared. And if we had y equals 6 minus x, we'd have x equals 6 minus y. Right, so we could have done 6 minus y squared dy. And I won't bother to go through and actually evaluate that integral because it should come out to be 22/3. Did any of you guys do it that way?
Yeah, I did, and it works.
Yeah, definitely should work. Yeah. Cool. Yeah, so either of those would be fine. The scoring guide does it in terms of x, and I believe yeah, they didn't write out they didn't do this one as an integral. They did it as the area of the triangle like we did. And that was a 3-point problem. So 1 point for doing the right integral, 1 point for having, 1 point for doing this integral, 1 point for the right antiderivative, and 1 point for the correct final answer. All right, so for part B, we got R as the base of a solid, and from y equals 0 to y equals 2, cross sections perpendicular to the y-axis are rectangles whose bases lie in R. So, our base is here, and our height is 2 times that value. It's 2 times y. And so if we're writing but not evaluating an integral expression that gives us the volume of this solid. So how do we go about that? I guess we'll give us a new page. Should be an integral from 0 to 2. If it's a rectangle and the width of it is the distance between those two functions in the y direction. That ought to be what we wrote for that part A if we did the other way, 6 minus y squared. And what is the height of each of those?
dy.
Just 2y,
dy.
b1. And that was worth 3 points, 2 for that, and 1 for that. Easy enough or no?
Yeah, good.
What was that? Everyone good there? Hopefully.
Yeah.
Perfect. All right. Let's take a look at part C. So what did part C want us to do? Part C said there's a point on the graph of f, and f is square root of x, right? Where the line tangent to the graph is perpendicular to the graph of g. And we want to find the coordinates of that point. So what does that tell us?
The slope of the tangent line should be opposite.
Right, our
Of G.
slope. So our slope of our tangent line should be the opposite reciprocal of whatever the slope of g is. Well, what's the slope of g?
-1.
And g prime is just -1. And so perpendicular to g must be a slope of 1. And so all we're looking for is when is the tangent line to f, and what's the tangent line to f? That'd be f prime of x, right? That'd be 1 over 2 root x. We want to know when does that equal 1. And so we're just looking for the x value at which that's true. And we go 1/2 equals root x, and x then equals 1/4. And I think it asks for the actual coordinates of the point, right? And so we'll need to say 1/4, comma, the square root of a fourth, which is 1/2. And the breakdown for that one was 1 point for the correct derivative of f, 1 point for setting it up as an equation like this, and 1 point for your final answer. Good or no? Any questions on that problem at all?
Nope.
All right, let's take a look at this one. That was a calculator problem that you worked on at home. Part A was pretty similar to the one we just did. If we wanted to find the area of R, what's the first thing that we would need to do?
Find where they intersect.
Exactly. And so you'd want to show that you wrote natural log of x is equal to 5 minus x. And you just use your graphing calculator to figure out when that was true. And what did that come out to be? Where did they intersect? At x equals 3.69344 is what they said. Is that what you guys got? Hopefully so. And then you just use your calculator for that. And then what did the y value come out to be for that? So what were the coordinates of this point? It was 3.69344, comma 1.30656. And so to find the area of R, we could either do it in terms of Y, and the linear minus the natural log function, or we could do it in terms of X, going from 1 to 3.6, and then from 3.6 to 5. So either one would be acceptable. I'll write out both. And in fact, I think on the scoring guidelines this time they wrote both. So you should have had an integral from 1 to 3.69344 of ln x dx, and then added to that an integral from 3.69344 to 5 of 5 minus x dx. So that was one option. And then the other option would have been to rewrite this. This is y equals ln x. You could write that as x equals e to the y. And if this was y equals 5 minus x, we could rewrite that as x equals 5 minus y. So you could have written the integral from 0 to 1.30656 of 5 minus y minus e to the y dy. And either of those would have been good. And the answer that you should have got was 2.986. So the answer itself was 1 point. Having the right limits was a point, and then having the right things inside the integral was a point. So 3 points for that one. Everybody good with part A? Both ways that it could have been done?
So there was like no way to solve that by hand, the 5 minus x equals natural log of x. Like you had to use your calculator.
Yep. I mean, you could write 5 minus x minus ln x equals 0 and approximate it using Newton's method, but that's a lot of work, especially if you're trying to do it by hand.
Okay.
Yep. Yeah, 5 minus x minus ln, or 5 minus x equals ln x. There is not a good way to find that value. All right, part B. This is now the base of a solid, and each cross-section perpendicular to the x-axis is a square. And so we want to write in, but not evaluate, an expression involving one or more integrals to give the volume of that solid. So since it's perpendicular to the x-axis, we've got to do it in terms of x. So we're going to integrate from 1 to 3.69344. Of the side length, which is natural log of x, squared dx. And we have to square it because the cross sections are squares. And then the same thing over here. Was it 5 minus x, right? From 3.69344 to 5. And that one was 5 minus x squared dx. And that's all you had to do. You didn't have to evaluate it or anything. To have this and this, each of those was worth a point. And to have the right limits, no, the full expression as a whole was worth another point. With the right limits and the right dx and all that. Any questions there on part B?
Nope.
All right. Part C. Part C is the one that usually trips people up. You've got some horizontal line. There it is, y equals k. That divides this region into two pieces of equal area. Obviously, I didn't draw that in the right spot, but that doesn't really matter. We want to write, we don't have to solve it, but write an equation involving one or more integrals that gives us the value of k if we were to solve it. So first thing we might want to do is say we know that the full area is 2.986, right? So half of the area, okay, two regions of equal area, means that each of those regions will have an area of half of 2.986. And we're looking for the value of k, which is a y value. So it would probably be convenient to do this in terms of y. And so if I were to integrate from 0 to k, the right function minus the left function, that should equal half of that area, right? So if I were to integrate 0 to k, what was it, 5 minus y minus e to the y dy is equal to half of 2.98, was it 2.986? If I were to actually go through and find this integral, which is an easy enough integral to find, 5y minus y squared over 2 minus e to the y, plug in k for y and then plug in 0 for y, set it equal to this and solve for k, it should give me the value at which the area is half of the full area. So 1 point for this, 1 point for having 0 and k, and 1 point for writing the whole thing out as an equation equal to 1/2 of 2.986. Good or no?
So in this problem, like the answer of one problem, you had to have that to get the full credit for this problem.
So no, technically you did not. This is an important point, actually. So you got some answer here for part A. Perhaps you got the wrong answer for part A, right? That doesn't mean that you can't get all the points down here. Suppose you'd gotten 7 as your answer. If you just wrote equals 1/2 of 7 here or equals 3.5, they would have given you the points for correctly doing part C. You would have gotten all 3 points if you'd had all of this the same. They don't penalize you for doing something earlier incorrectly, even if it's required for something later, especially if it's like a write but don't evaluate. They would have still given you points for that.
Okay.
Any other questions on that? All right. In that case, how are we feeling about these area and volume free response questions in general?
Generally
Pretty good.
Good.
Generally pretty good. Okay, that's good. Generally pretty good is good. If we have time today after going through the derivative multiple choice, we can do a couple more of them. Otherwise, I'll just post a few up for you guys to practice with tonight that we can go through tomorrow. But now we will move on to some of the multiple choice. So if you have any questions from any of the derivatives multiple choice packet, now is the time.
Can you go over number 22?
Sorry, I didn't hear what you said. Which number?
22.
22. Okay. All righty, let's see there. I guess I have to open up my book with all these questions. Number 22. Somewhere in here. All right, so number 22 says, we're just looking for dy dx, and we've got x plus cosine of x plus y equals 0. That's the right one, yeah?
Yeah.
Okay, so we're looking for the derivative of this. We've got cosine of x plus y within here, which makes this one that we're really going to want to use implicit differentiation for. So we'll take the derivative of the x, that's 1. And then the derivative of cosine of u should be, derivative of cosine is what? Negative sine, right? So minus sine of u. And then that has to get multiplied by the derivative of that u by that x plus y. So the derivative of x is 1, and the derivative of y is dy dx equals 0. Good so far?
So would you not expand the cosine of x plus y using the identity?
No, I definitely wouldn't do that.
Oh, okay.
Yeah, especially not looking at the answer choices. Like if you look at the answer choices, most of them have, you know, a sine or a cosecant or something of x plus y in it. So I wouldn't
Okay.
do that. Yeah, so then we have 1 minus sine of x plus y, if I'm distributing the sine of x plus y to the 1, and then minus a dy dx times the sine of x plus y equals 0, and we'll bring that over. So we end up with 1 minus sine of x plus y equals dy dx times sine of x plus y. When I bring that to the right side, we'll divide by the sine of x plus y. And 1 over sine of x plus y is cosecant of x plus y. And negative sine of x plus y over sine of x plus y is a minus 1. And so it looks like that is choice A. Does that make sense? Good with that?
Yeah, thank you.
And one thing to note for all of you here that all of these multiple choice questions have 5 answer choices, which is how the AP test used to be, but they've changed it. And nowadays, all of the multiple choice only have 4 answer choices. So that makes your life a little bit easier. All right. Any other questions? I assume there's more questions. So let's see how somebody's 29. Okay. 29. So 29 says we've got a point moving on a curve. The curve is x squared plus y squared equals 25. And we're interested in what is the second derivative of this at the point 0, 5. Okay. So first off, we're going to take the first derivative. And I'm just going to use implicit differentiation here. The derivative of x squared is 2x, and the derivative of y squared is 2y dy dx, and the derivative of 25 is 0. So solving that for dy dx will be the first step here, because we need that to find the second derivative. So dy dx equals, I'm going to bring the 2x over to make it a negative 2x, and then I'll divide by the 2y. And I can simplify that to negative x over y. And then from there, we will find the second derivative. And then that means we're taking the derivative of this. And so that's a quotient of 2 functions. So we'll use the quotient rule. I'm going to treat the x as a negative x. I'm just going to apply that negative to the numerator. I could apply it to the denominator. We'll get the same thing. Or I could just put a negative out in front and then do the derivative. It's all the same. So I'm just going to apply it to the x. So denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. And we're interested in what this is at 0, 5. So at 0, 5, what does dy dx equal? Just dy dx should be 0, right? So then we just need to plug in the y's over here. So if I evaluate this at the point 0, 5, y is 5, so that becomes negative 5. And then that becomes plus x, which is 0, times dy dx, which is also 0. over y squared, which is 25. So we got negative 5 over 25, which is negative 1/5. Good or no? And that was, what was that, answer choice D? Yeah, so it's just an addition to what somebody had sent me in the chat. You can either plug in the dy dx as negative x over y over here, or if you've done that, you'd end up with plus x times negative x over y, and then you just plug in the 0 for x and the 5 for y into that, or you can plug in the 0 and the 5 into the dy dx, and then just replace dy dx that way. So either way would work.
Can you do number 31?
Yeah, I got a couple people that have sent me ones before in the chats. I got 13, and then 12, and then 52, and then you said 31.
Yeah, I can type it in the chat for you.
Sure, yeah. If you guys just type them in the chat, I'll just go through in the order that I get them. So now everybody's gonna be typing in the chat. So we've got 13 next. All right, 13, we're looking for, let's see, what is I assume the whole thing there is find the derivative of it. Is that right? Yeah, find the derivative. So 13 was y equals natural log of the square root of x squared plus 1. So this is a chain rule within a chain rule. So it's natural log of u. So we're going to take the derivative of natural log of u, which is 1 over u. And then we've got to take the derivative of square root of x squared plus 1, which is again the chain rule. That's the derivative of square root of u. So that should be the derivative of root u is 1 over 2 root u. And then we got to multiply that by the derivative of x squared plus 1. So our 2's will cancel out. And it looks like we should get x over x squared plus 1. So that's 13. Does that make sense on 13 there? Everyone good on 13? All right. Let's move on to 12. So number 12 was y equals e to the x minus e to the negative x over e to the x plus e to the negative x. Okay. So this is a quotient of two functions, so we'll use the quotient rule. That should give us denominator times the derivative of our numerator. And the derivative of e to the x is e to the x, and the derivative of e to the negative x is a negative e to the negative x. So that will become e to the x plus e to the negative x. And then we'll subtract the numerator, e to the x minus e to the negative x, times the derivative of the denominator, which is e to the x, and the derivative of e to the negative x is again minus e to the negative x, all over our initial denominator squared. Everybody good there? All right. So then let's distribute out our numerator. E to the x times e to the x is e to the x squared, or e to the 2x. And then e to the x times e to the negative x, if you add the exponents, that becomes e to the 0. So that'd be plus 1. And then I'm going to have another e to the x times an e to the negative x there. It's going to be another plus 1, so that'd be plus 2. And then e to the negative x times e to the negative x is e to the negative 2x. Then minus all of this stuff distributed through. So e to the x times e to the x is e to 2x. And then once again, the e to the x and the minus e to the x is going to become just a -1 there. And this will become another -1, so -2. And then minus e to the negative x and minus e to the negative x should become plus e to the negative 2x. And all of that is over e to the x plus e to the negative x squared. And so then this stuff in the numerator should all simplify down pretty nicely. E to the 2x minus e to the 2x should cancel. E to the negative 2x minus e to the negative 2x should cancel. And then we have 2 minus negative 2, which should give us 4 over e to the x plus e to the negative x squared. Good or no? Any questions on that one?
Good.
All right. Next one I've got on my list here is 52. All right, 52. 52 is actually a limit question. The limit is x approaches 0 of secant x minus cosine x over x squared. So if we were to plug in 0 to this, secant of 0 is 1, cosine of 0 is 1 over 0 squared. So this is 0 over 0. So we would then go ahead and try and use L'Hopital's rule for this. So that gives us a limit as x approaches 0 of the derivative of secant is secant x tangent x. And the derivative of negative cosine should be positive sine. And then the derivative of x squared should be 2x. So this was using L'Hopital's rule. Secant of 0 is 1. Tangent of 0 is 0. So that's 0. Plus the sine of 0, which is still 0, over 2 times 0, which is also 0. So I got another indeterminate. So we'll use L'Hopital's rule again, giving us a limit as x approaches 0. And then the derivative of secant x tangent x, we'll have to use product rule for that. So that would be secant x times the derivative of tangent x, which is secant squared x. And then plus tangent x times the derivative of secant x, which is secant x tangent x. And then plus the derivative of sine x, which is cosine x, all over 2. And this is secant cubed. And if we're doing secant of 0, the secant of 0 is 1. So 1 cubed is 1. And then tangent of 0 is 0. And secant is 1, but tangent is again 0. So 0 times 1 times 0 gives you 0. And then cosine of 0 is 1 all over 2, which should give us 1. It's like that was choice C. Good or no? Just 2 applications of L'Hopital's rule to get through that one. All right, let's see, that was 52. Next one on my list is 31. Let's take a look here. Let me flip back in the book. Okay, so 31. What does 31 say? It gives us f of x is 5 to the x, and it tells us that 5 to the 1.002 is about 5.016. And we want to know which of the answer choices that it gives us there is closest to f prime of 1. So what this is basically asking us to do is take a look at the tangent line and use the tangent line to approximate the derivative at 1. And so the tangent line, or sorry, not the tangent line, but use the secant line, use the slope to approximate the slope of the tangent line at 1. And so our slope should be 5 to the 1.002 minus 5 to the 1. That's the smallest interval that I know, over 1.002 minus 1. And 5 to the 1.002 we know is about 5.016 minus 5 divided by 0.002. And so that's just asking us what is 0.016 divided by 0.002. And that should be, what does that come out to be? That comes out to be 8. So we're just using a tangent line to approximate it. I keep saying tangent line. We're using a secant line, using the slope to approximate the tangent line. Does that make sense? Any questions on that one?
Yeah, that makes sense.
Okay. Let's see here. I believe the next one I had was 11. Let's see. Go back to 11. So for 11, we're looking for the derivative of natural log of secant x plus tangent x. So this is natural log of u. So it should be 1 over u. So 1 over secant x plus tangent x times the derivative of secant x plus tangent x. Derivative of secant is secant x tangent x. And the derivative of tangent x is secant squared x. And my guess is they simplify this down. Yeah, so this is a pretty standard derivative that pops up a lot, because oftentimes we need to figure out what's the integral of secant x, and this is how we do it. But that's a separate point. So we can take the secant x out of the numerator, leaving us with tangent x plus secant x over secant x plus tangent x. And those will cancel, leaving us with just secant x. Is that good for number 11 there? Choice, what is that? Choice A? Everyone good with that? All right, now we've got the long list of questions that Alex has typed in here. So next one on our list is 32. So 32, we've got y equals e to the x times x minus 1. And we want to know what is y double prime of 0. So first thing we need to do is find y double prime. So first thing in order to do that is to find y prime. This is a product rule. So it'll be first function times the derivative of the second plus the second function times the derivative of the first. Second function is x minus 1. Derivative of e to the x is just e to the x. Then we need to find y double prime. And you can either factor the e to the x out of these if you want, which actually probably makes things easier. If we do that, we could take the e to the x out of that, which gives us e to the x times 1 plus x minus 1, or just x e to the x. And so we can take the derivative of that, which should be x times the derivative of e to the x plus e to the x times the derivative of x. And so that's our second derivative. If we evaluate that at 0, this will become 0 times 1 plus 1 times 1. So looks like that's choice D. And if you hadn't factored the e to the x out of that, if you'd just taken the derivative of this, derivative of e to the x is e to the x, and the derivative of e to the x times x minus 1, well, we had just done that. That would be e to the x plus e to the x times x minus 1. And that would give us, if we were evaluating that at 0, 1 plus 1 plus 1 times negative 1. So 1 plus 1 minus 1. So plus 1. Any questions there with 32? Everybody good with that one?
Yeah, good there.
Okay, next one we got is 59. Is that moving into the calculator ones?
Yeah.
The potential calculator ones? Okay. All right, 59. So for 59, they give us this chart. Just that enough? That's enough, yeah. So they give us x, they give us f, they give us f prime, they give us g, they give us g prime, and values at 0, 1, 2, and 3. So just in case somebody doesn't have it in front of them right now. I don't know why they wouldn't, because it's what we're doing. But there's the chart. And it says that f and g are both differential functions, so there's derivatives at all values of x. So now I forgot what number we were doing. 59?
Yeah, 59.
Okay. So d, the function d, is equal to 1 over g prime. And it asks us to find d prime of 1, which means we got to find the derivative of d. And so this is just a reciprocal rule. If we were to look for the derivative of that. So the derivative of, is it 1 over g or is it 1 over g prime? No, that's not a prime. That's just a comma. If d equals 1 over g.
Oh, that's not a G prime?
No, that's a comma. If you look at it more closely.
Then that takes away my question, because my whole question was like, how do you get, like, find the derivative of G double prime if it's not given?
Yeah, no, you don't have
So
to.
then I should be good there then.
We'll do it just in case anybody else is wondering. This is 1 over g. I misread that for a second as a prime. Yeah, if you look, I mean, if you look in the notation, you can see the prime and the commas look a little different.
Yeah, I guess.
So d prime of 1 just means find the derivative of this, and the derivative of 1 over g, while using the reciprocal rule, that should be negative g prime over g squared evaluated at x equals 1. And so that's negative g prime of 1 is negative 3. And g of 1 is 3. So 3 squared gives us 3 over 9, or 1/3. That makes sense to everybody? Now that you can read that as a comma, not a prime.
Yeah.
All right, next one we got here was, that was 59, right? So 66. So 66, they give us something that looks like this. and say that this is the graph of f prime, and this is A right here. And it says, it gives us a bunch of different options here. So option A is that which of the following statements must be false. And so let's see, f is continuous at x equals A. And so just because our derivative doesn't exist, right? So we can say f prime does not exist at A, but just because your derivative doesn't exist at a value doesn't mean that the function is not continuous. So we're gonna say A, which is f is continuous. This is possible. It could still be continuous, right? That's not guaranteed to be false. B says f of A equals 0. Well, f of A being 0 has absolutely nothing, like the value of it has absolutely nothing to do, the value of the function has absolutely nothing to do with its derivatives values. So that doesn't make any sense. Choice C is, what is it? Has a vertical asymptote at x equals A. And so this is the one that we should say is definitely false, because if we have a vertical asymptote, what does the derivative do? F prime at a vertical asymptote is either positive or negative infinity. And it's neither positive nor negative infinity there. So we're guaranteed that this function f, the integral of f prime, does not have a vertical asymptote at x equals A. It's got some other kind of discontinuity, maybe, but we don't know that for sure. D and E are both what it says, it must be a jump discontinuity, and choice E says it must be removable, but we don't even know, we don't even know if f is continuous or discontinuous there. So it could have a jump discontinuity, it could have a removable discontinuity, it could be continuous there, but it definitely doesn't have a vertical asymptote. Does that make sense to everybody? 66 there?
Yeah.
All right.
So what would the derivative graph look like if it were to asymptote? Like instead of that linear piece, would it just be like, okay. That makes sense.
Yep, the derivative would have to be going towards positive or negative infinity. Yep. All right, next one here on this list is 73. Okay, 73. We want to know at how many points on the interval -5 to 5 inclusive is a tangent to y equals x plus cosine x parallel to the secant line. When is it parallel to the secant line? And so this question is sort of like it's a mean value theorem for derivatives question, basically. We want to know how many times though, and so we don't really, we could go through and we could go through and we could say, well, when does x plus cosine x actually equal its derivative? But the easiest thing to do here is I'm going to pull up a graph on Desmos and graph x plus cosine x, which is what you could do on your graphing calculator. And if we were to do the secant line between -5 and 5, the best way for me to do this on here. Just to kind of look at it this way. If I were to,
Desmos.
oh, I'm sorry. So if I were to graph this from -5 to 5, you can see Desmos now, yeah?
Yeah.
We should be able to see that each of these little humps that we get in here are places where our tangent line should be parallel to our secant line. So you can just, I mean, just by looking at it, you should see that there's one place right here, because right here our slope is less than this slope between these 2 points. And over here, my slope is greater than the slope between those 2 points. So there must have been a spot over here. There's 1. Here it was greater than, it went to less than. So there must be a place in between here that makes 2. And here it was less than, and here it became greater than again. And so it must have been a third place. So it looks like there should be 3 places where it's parallel to the secant line. Just by looking at when the slope is less than to when the slope is more than that secant line.
So when they talk about the secant line between what 2 points? Because they didn't like specify.
Well, the secant line of the function means that, well, I mean, they're talking about the secant line on -5 to 5.
Are they
No.
just any secant line?
Well, there's only one secant line between -5 and 5. It's the
Okay,
point,
okay.
the one that goes through -5, comma, whatever that point is, and the one that goes through the point 5, comma, whatever that point is. So there's only one line that goes through those 2 points.
Okay.
Does that make sense?
Yeah.
Any other questions there? Anybody on 73? Okay. Next one is 78. Oh, it is 78 asking us if f is differentiable and difference quotients overestimate the slope of f. So f is differentiable, but a difference quotient overestimates the slope. Which of these many things must be true? And so let's just sketch a quick graph. If the difference quotient, what's the difference quotient? The difference quotient is not the limit as h approaches 0 of the difference quotient, but just the difference quotient itself. This is just the slope of a secant line through the function. So if I were to draw a function that looked like this and use the secant line to estimate the slope on this interval anywhere, if the function was concave up, a secant line will always overestimate the slope. So we need to have a function that is concave up. And the only one of those that it tells us it's concave up for our values there is choice C. F double prime is greater than or equal to 0. And that tells us that our function is always concave up. If we had a function that was concave down, the secant line would underestimate it because the value from the secant line is less than the value of the function. And if we're thinking about a tangent line, if the function is concave up, the tangent line underestimates the slope. And if the function is concave down, the tangent line should overestimate the slope. Everybody see that?
So with the
very
f
important thing to know.
double
I know we-
prime,
Say that again?
with the f double prime greater than or equal to 0, was that like the second derivative test or something like that?
Yes, exactly.
Okay.
Yep. And so that's actually a very, very important problem there to think about when a secant line and a tangent line under and overestimate the value of a function, right, or the slope of the function. Okay, so keep that one in the back of your head. All right, next one after 78 was 85. 85 gives us f of x equals 2x cubed minus 3x. And h is the inverse of f. And we want to find h prime of -1. So if f of x is this, then that should tell us we could be able to find its derivative pretty easily. F prime should be 6x squared minus 3. And according to the inverse rule, that means that h prime should be what? Should be 1 over 6x squared minus 3. And if we are, what are we looking for? We're looking for the value of this at, now I lost the value of h prime at -1. So all we got to do is plug in -1. That'll be a third. Good or no? Everybody good with that one?
Yeah.
All right, next one. That was 85, right? Next one we got here is 88. 88, we've got the limit as x approaches 0 of g of x minus g of 0 over x equals 1. And then it gives us a bunch of different things to think about. It says g is not defined at x equals 0, g is not continuous, and so on. The one that we should be seeing there, though, that makes sense, though, is this is effectively one of our two limit definitions of the derivative, right? The limit is x approaches a of f of x minus f of a over x equals f prime of a. And so this is just this exact same thing. It's g of x minus g of 0 over x is the derivative. So this should be g prime of 0. That's just a limit definition of the derivative. So g prime of 0 equals 1 is guaranteed by that. Good or no?
So was that early on when we were just doing like intro into derivatives? Was that where that rule came from?
Yep. This is right, we mostly use this one. But this one, we briefly mentioned it at some point as well. That this one shows up too.
Okay.
Same thing. Function's value at x minus the function's value at a divided by x is f prime of a. All right. Next one here, what are we looking at? 89. All right, 89, they give us a graph and ask, let's see here. Like this, and they're asking us to approximate f prime of 3. 3 is like over here somewhere, f prime of 3. And what do they want you to just, yeah, I mean, basically all they want you to do is look for a couple of, that's a really poor problem. The only way you're going to be able to go about doing that is to find, you know, a couple of values that are lying on that line and just sort of basically approximate the value. Like if you look at maybe what does it look like it is at 2? Maybe at 2 it's just below, maybe just below -3, like -3.2, let's say. And if you look at the value at 4, maybe the value at 4 is like just above -2, so maybe like 1.8. And that's the only way you're going to be able to approximate that, is just by taking a couple of points there and subtracting them. And sorry, not -1.8. And so if you subtract those, what do you end up getting? Looks like negative, we'll do it the other way, -1.8 minus -3.2 over 4 minus 2. What does that come out to be? 1.8 plus the 3.2 is 1.4. 2, so that came out to be about 0.7. So it looks like about 0.8, which makes sense. It's definitely not more than 1. If you just look at it, might be right around 1, might be a little less than 1, but it's definitely not up to 1.5, and it's definitely not as small as 0.3 for the slope there. I mean, you could just kind of ballpark it by eyeballing it, but if you want to plug in a couple points and divide, you get something close to 0.8.
Okay, so the right answer was 0.8.
That's what I would say. Yeah.
Okay. So you would just have to really just try to pick a couple points off of that and just go for it, I guess.
Yeah, or I mean, or you can just sort of eyeball it. But yeah, 0.8. Yeah, I would pick a couple points and just ballpark it. All right, let's see, 24. Let's see, moving back to 24 here. 24 was another implicit differentiation one. So 3x squared minus 2xy plus 5y squared equals 1. And we're just going to take the derivative of this implicitly. So the derivative of 3x squared is just 6x. Derivative of minus 2xy will be minus 2x times the derivative of y. And then plus the derivative of minus 2x, which is just minus 2 times y. And then plus 10y dy dx equals 0. And we'll take everything with the dy dx to the other side. So we have a 6x minus a 2y on the left, and a 2x plus a 10y multiplied by a dy dx on the right. Those are all divisible by 2, so we might as well do that. And we're going to divide by the x plus 5y that's left. And that should give us, I don't know, let's see. What number was this, 24? Yeah. Oh, did I make a sign error somewhere in there? I don't see that answer choice. 6x minus 2x dy dx plus negative 2y plus 10y dy. Oh, this should be a minus 10y. It should be a minus 5y. So 3x minus y over x minus 5y, which doesn't look like any of the answer choices, but if you factor a negative, right, you can take a negative out of the top and a negative out of the bottom, which gives you y minus 3x over 5y minus x, which was choice B. Any questions there on 24? Everybody good with 24? I got 2 left that people have asked for. So next one is 90, and then we're going to do 76, and then we will be done. Let's see here. Number 90. Number 90 was that same graph. So let me go back to here. 90 was the same graph from number 89. And it says the rate of change of f of x. The rate of change of f of x is at least, let's see. Okay, yeah, okay. So the rate of change of f of x is at least some value of x. And so our rate of change of our function, meaning our slope, right? Our slope should be at its smallest value at our point of inflection, right? Because that should happen. Our function is got its largest negative slope here at its point of inflection as it goes from being concave down to concave up. And so it looks like that point of inflection probably occurs somewhere between 0 and 1 is my guess, because the distance between here and here is definitely not at 0, like it's not even between 0 and whatever that is, and that's like negative 1.5, and this is about 3. So somewhere between these two values is about 0.7 is where that point of inflection is, most likely. And that's not a very good question either. I wouldn't expect to see something exactly like that. But your rate of change is always at its smallest value at your point of inflection here if you've got a regular cubic, which happens at x equals 0.7. So yeah, I don't like that question, but I wouldn't expect to see that. And then our last one is 76. I know we're like a minute over here. We've got a function y equals x squared minus 8x plus 10. And for x less than or equal to 4, we're saying this is a one-to-one function. Its inverse is also a function, and we're calling that inverse g. And we want to find g prime of 3. And so if we're looking for g prime of 3, we just need to, if we were to take the inverse or the derivative of this, our derivative should be y prime equals 2x minus 8. And our inverse should be 1 over 2x minus 8. And we're looking for g prime at 3. And so g prime at 3 means we need to, since we can't actually use 3 because, so if let me sketch the graph out for this, x squared minus 8x plus 10x is less than or equal to 4 is like, this is our parabola, and here we are at 4. And so we can't actually use this value at 3, unfortunately, because we're talking about, I don't know why I put my axis in the wrong spot here. Let me re-sketch this. Here's 4, and it looks something like this. So we have to find the place at which our function equals 3, but is within our domain. So our function equals 3 at both what two values? should be that x equals 7 and x equals 1. And so we have to pick the correct one of those to use. And so we have to pick the one that falls within x is less than or equal to 4. So that'll be at x equals 1. So we'll evaluate this at x equals 1, which gives us 1 over 2 minus 8, or negative 1/6. So we just got to be careful about which of these values we choose. We have to pick the right one between less than or equal to 4. Does that make sense? For anybody still out there?